Hello everyone. In this video we're going to be solving a Quartic equation. We have x to the fourth power equals 5x squared plus 6x plus 5, and we're going to be solving for x values. This is a Quartic equation because its degree is 4 and there is a Quartic formula, which is something you never want to use. It's gigantic. So let's see how we can approach this problem from two different angles or with two different approaches. First method, I'm going to go ahead and try to solve this equation sort of like using the idea from, I wouldn't necessarily say Quartic formula, but there are different methods for solving Quartics, and this would be one of them. So we want to turn this into a difference of two squares, and this problem is actually a really good example of that. You'll see in a little bit how that works. But before that, let's go ahead and talk about something else. Let's subtract everything, turn this into a full Quartic. Now notice that this is not a full Quartic actually, because it's missing x cubed, which is nice, by the way. It's called a depressed, I think, right? Is it reduced? Not reduced, but depressed Quartic. So it's already good to go. So we're going to do the following. We're going to write this, or try to write this, as a product of two quadratics. That's going to be our first method, okay? So like this, x squared plus ax. Yeah, sometimes that happens with Desmos, I don't know. I mean, notability. X squared plus ax plus b. And then we're going to multiply this by x squared minus ax plus c. You'll see in a little bit why I wrote it that way. And then this should equal my Quartic, okay? Now, why did I write plus ax and minus ax? Think about it for a minute. This is the reason. When you distribute, you're going to get x cubed in two ways. By multiplying these two things and by multiplying those. Those are the only ways to get x cubed. And guess what? We don't want it. Because there's no x cubed, we need to get rid of it. And that actually reduces the number of variables. Even if you used more variables here, like 4 variables, a, b, c, d, you will still have to get rid of that at some point. But this is a little easier method. So let's go ahead and distribute the left-hand side. We're going to get x to the fourth. Don't worry about x cubed because that's not going to happen. Well, let's see which x squared values we're going to get. So you can distribute this x squared over the c, so you're going to get cx squared. And then that's it. Ax by negative ax. Of course, that's going to give you negative a squared x squared. And then finally b with x squared. That's going to give you all the x squared you need. Make sense? There's 3 ways. And then to get x, we're going to need to distribute the ax over c. That's going to be a cx. And then we're going to distribute the b over negative ax. That's going to be negative abx. And then finally, to get a constant, we're going to multiply constant by a constant, which is bc. Now let's go ahead and rearrange the terms a little bit. I can write this as b plus c minus a squared. By the way, this pattern is always going to come up the same on the left-hand side, so you might as well just take note. Plus ac minus ab will be the coefficient of x. And finally, our constant will be bc. Okay? Now, if you set this equal to our Quartic, which is x to the fourth minus 5x squared minus 6x minus 5, you're going to notice the following. You're going to get a system of equations with 3 variables. Isn't that awesome? So this is going to be negative 5. This is going to be negative 6. And this is going to be negative 5. A lot of negativity, right? So let's go ahead and write each of these. b plus c minus a squared is negative 5. AC minus AB is negative 6, and BC is negative 5. Okay, great. So 3 variables and 3 equations. So that should be solvable, right? Yes, but not with ease. Because if you go ahead and take a look at it, this is going to turn into a cubic. Why? It kind of looks quadratic, but you have to make some substitutions which will make it cubic. But cubic equations can be solved, right? Well, at least we can do guess and check. If the solutions are, or I shouldn't say solutions, but if the coefficients are integers, then they should be easy to find. You could even guess and check. So here's what we should do at this point, I think. From the first equation, isolate b plus c, write it as a squared minus 5. And then from the second equation, take out an a and write it as c minus b times a equals negative 6. And from here, isolate c minus b by way of division and write it as negative 6 over a. Awesome. This is going to be very helpful because if you pay attention, from here you're going to be able to solve for b and c in terms of a. Great. And then you can go ahead and plug it in here. For example, if you add these equations, b is going to cancel out. We're going to get 2c, or not 2c. Well, I should have known b first, so I should get 2b. But you get the idea. And by division, we're going to get c. So 2c is going to be a squared minus 5 minus 6 over a. You can write this as a cubed minus 5a minus 6 over a. And then c will be a cubed minus 5a minus 6 over 2a. And of course, b will be very similar to this. And then by substitution, you can just go ahead and look at their product here. Set it equal to negative 5, you'll get a cubic equation. Well, first you're going to get a hexic, but that's going to be a bihexic or bicubic. And then you'll turn it into a cubic equation and solve it. Okay, makes sense? That's a very long story, so it's going to be left as an exercise for you. Okay, please don't hate me for that. Now let's go ahead and take a look at the second method, because I think the second method is just awesome. And of course, there's a reason for that. I know some people are going to complain about it, like, oh, this problem has been contrived. Of course, that's all what all the competition problems are. Obviously, you wouldn't give people something that wouldn't work or that would be super ugly when you work it out. Okay, because they have limited time. Now, it's not a research problem, so it's just a competition level problem. So here's what we're going to do. Like I said earlier, we're going to try to write this as a difference of two squares. So that means I do need a perfect square on one side, another perfect square on the other side. So kind of like this. P squared equals q squared. Because what this turns into is p squared minus q squared equals 0. And then I can factor it into p plus q and p minus q. In this case, p and q represent polynomials. Okay, great. I didn't write p of x. I just wrote p and q. Shortcut. Okay. Let's see how we can do it. First of all, I have x to the fourth. So that would make sense if I had x squared plus something squared, right? Okay, great. So that might help me like write this as x squared plus k squared. What about the right-hand side? Here's the critical part. The right-hand side is quadratic. It's going to stay as a quadratic. It's probably going to be ax plus b squared. And then if you do this and set it equal to original expression, of course, get rid of the x cubed, which is not going to come up anyway, so you don't have to worry about it. And hopefully you can find it this way too. But that's my goal. I'm not going to try to search for KAB, but more like I'll just try to make it happen, okay? Here's what we're going to do. First of all, I want to focus on 6x because I don't want to add x to both sides, because adding x term will mess up the left-hand side. Notice that this only contains x to the fourth and then x squared and a constant. You see what I'm saying? So you don't want x on the left. That means you're not going to add it. So 6x is going to stay. And then that kind of reminds me, as every time I see 6x and think of perfect squares, this is what I remember, right? Don't you think? This is a really nice perfect square. So I'd like to have it on the right-hand side. Can I? Sure. Let's do it. X to the fourth equals x squared plus 6x plus 9. And then I'm just going to add the additional terms. I do need a 4x squared. And then I do need to subtract 4 to get 5. Make sense? Isn't that awesome? Because everything that I needed on the left-hand side just showed up. So let's go ahead and subtract these things, and we're good to go. Okay. Again, that's very contrived. That's why things just fell into place. So here we go. We got our perfect square, and that's just perfect. Now, we're going to do the following. We're going to write this as a perfect square, of course, and this one. You see how 6x was helpful, and not adding x term was also helpful. Anyways, now the rest is fairly easy because all you have to do is turn this into a difference of two squares and then just factor it. Of course, this is equal to 0. And I'm going to go ahead and write it like x squared minus 2 plus x squared plus 3. That's going to be a plus b, and then or p plus q, and then p minus q equals 0. And from here, if you arrange the terms, you're going to get, I kind of messed up somewhere. Yes, of course. This is supposed to be x plus 3, not x squared plus 3. Okay, I kind of over squared it. And this is going to be x squared minus 2 minus this. Okay, so this will be gone. Okay, here we go. Now this is good. And now I'm going to write it as x squared plus x plus 1. Uh-oh, that doesn't have real solutions, but that's okay. X squared minus x minus 5 equals 0. Awesome. This one doesn't have real solutions, but if you want to write it, those are actually going to be the cube roots of 1, except for 1. So they're going to be negative b plus minus the square root of b squared minus 4ac, which is going to be square root of 3i divided by 2. And I know I messed up on one of the problems on a plus b. I'm going to fix it. And this one is going to give me negative b plus minus the square root of b squared minus 4ac. That's going to be square root of 21 divided by 2. And those are going to be the real solutions. Let's go ahead and take a look at the graph of these two functions and where they intersect. Yes, there are 2 intersection points, as you can see, and we found 2 real solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.